sorting algorithm. So any comparison based sorting algorithm can be represented by a decision tree for each fixed can. So and then number of leaves. We have the leaves. Any comparison based sorting algorithm can be represented by a decision tree. Second point, it have number of leaves. So that is greater than n factorial. The third point is height of the binary tree with n factorial leaves greater than or equal to n log 2 n. That is log 2 n. So minimum number of comparisons in the worst case is greater than log 2 n factorial. The minimum number of comparisons in the worst case is greater than or equal to log 2 n factorial. So this log 2 n factorial. So for any comparison based sorting algorithm, since the longest path represents the worst case and its length is the height. And then that is log 2 n factorial is approximate or equivalent to n log 2 n. So that is the Stirling approximations. What is that? It means log 2 n factorial is approximately n log n. Okay, this one is the Stirling's approximation. So this is the lower bound is tight, that is back sort or keep sort. And that அங்க வந்து என்ன ஆகும்னா lower bound வந்து ரொம்ப டைட்டா இருக்கும். Tight lower bound நம்ம படிச்சோம்ல, so that is. And then and the next one is adversary arguments. So what is the adversary argument? It is like game between the adversary and the unknown algorithm. So it is the game between the adversary and the algorithm, that is unknown algorithm. So adversary has the input and the algorithm has asked questions to the adversary about the input. The input the adversary tries to make the algorithm work the hardest by adjusting the input, that is consistently. So it wins the game after the lower bound time. So it wins the game after lower bound time, that if it able to come up to two different inputs. That எப்படி இருக்கும்னா two different input ல. So இந்த இடத்துல வந்து நாம lower bound have been proven. So first example is guessing a number between 1 and n. Guessing a number between 1 and n using yes or no questions. இத வச்சு yes or no questions வச்சு நம்ம என்ன பண்ணனும்னா prove பண்ணனும். So in this example, the adversary puts the number in a larger of two subsets generated by last question. So example 2 is merging two sorted list of size n. That is a less than a2, a1 is less than a2, less than up to less than an. அதாவது a1 less than a2 less than a3 up to an வரைக்கும். And b1 less than b2 less than b3 up to bn வரைக்கும். அதாவது ரெண்டு sorted list வந்து நம்ம எடுத்துட்டு என்ன பண்ண போறோம்னா அது merge பண்ண போறோம். இது செகண்ட் எக்ஸாம்பிள். சோ அது அங்க வந்து adversary எப்படி யூஸ் ஆகும்னா, so keep the ordering b less than a1 less than b2 less than a2 up to bn less than an in mind and answer comparisons consistently. So here we have to claim any algorithm requires at least 2n minus 1 comparisons to output the above ordering. So because it has no compare each pair of adjacent elements in the ordering. So what's the example here? Design an adversary to prove that finding the smallest element in a set of n elements requires at least n minus 1 comparisons. The next topic is lower bound by problem reduction. So what is the fact here? If problem 2 can be reduced to problem P, then